questions yesterday. In calc, we mostly see basis of e, the natural exponential. We probably never called it the natural exponential before, but you know that the log that goes along with it is the natural log. So typically in calc, we will always see natural logs and the natural exponential. And we know e is kind of a number, just like pi, it's like 2.7, it's this long decimal that goes forever. We could certainly graph these as well. So as a refresher from yesterday, what would my parent function be? E to the x. Okay, so if I put in -1, 0, and 1, remember that was what we did on our t-chart. If you type in e to the -1 on your calculator, since it's not a nice number, what do you guys get?
0.3678 or 3.679.
We'll say 0.37. Okay, if I put in a 0, we know we always get 1. If I put in a 1, we just get e, which you could certainly type in if you wanted on your calculator, if you were really interested in all those decimal places. But we could just say the 2.7 approximately. So that's my parent function. What's the transformation on this one?
Flip across the y-axis and down.
We have a negative right here, which is changing the signs on all of the x's. So it flips over the y. And this one will go downward. We know up and down moves our horizontal asymptote, so we now have a horizontal asymptote at -1. Okay, so if I take this point and flip it, it would come over here, downward. If I flip this, it doesn't go anywhere, downward. Flip this one, it comes over here, downward. What's our domain? Always? And our range? And then -1 gets put C because it's not equal to -1. Alright, so that was a little bit of a refresher from yesterday. Today we're really going to focus on our logs. So if I run through our definitions, remember the log is just the inverse of the exponential. It can always be written as an exponential. The base of the log and the base of the exponential are the same number. And you go across the equal sign. So it's a to the y power equals x. So a log is really giving you an exponent. Properties of logs. If you have the log of two things being multiplied together, how do you break those apart? Log base A of x. What's log base A of y? That has to do with our properties of exponents. You know, if I said like 2 to the x times 2 to the y, we end up adding those exponents, so that's why when we break apart the logs, we add them. If you were dividing, what do you do with your exponents? Subtract them. So this would turn into log base A of x minus log base A of y. What happens if we have an exponent? Remember? Yes. Turns into a coefficient. The common log, remember, is just written as log. That's the same thing as saying log base 10. So common log is base 10. Natural log was the ln, and that's the same thing as log base e. So if you see an ln, your base is e. If you see log without a base written, we assume it's 10. Is that okay? So let's graph some logs. We know f of x is the same thing as saying y. And what we did anytime we wanted to graph it is we rewrote it as an exponential. The base of ln is e, so that means e to the y power equals x. So when we make our t-chart, now y is the exponent. So that's my -1, 0, and 1. What's e to the -1?
0.37.
Was it 36 or 37? 37. Okay, e to the 0 and e to the first. Because it's the inverse of the exponential, notice it just flips the x and y values of those points. So 0.37, -1, 1, 0, 2.7. Alright, and if I asked you to do something like natural log of x plus 2 or something like that, we could just apply transformations to this. Any questions on that one? Let's do log base 3. So that's saying y equals log base 3 of x. So 3 to the y power equals x. T-chart, y is the exponent, so that's your -1, 0, and 1. What is 3 to the -1? 3 to the 0. And 3 to the first. One, 1, 0, 3. And if I look at these graphs, my exponentials had a horizontal asymptote. What kind of asymptote do these have? Vertical. So these, if you were doing transformations, moving it left and right would move your vertical asymptote. Up and down wouldn't affect it. So these have an asymptote at the y-axis. No questions there? So I'm trying to use my logs. And we know a log finds an exponent. Do I know 2 to what power equals 80? No. So how am I supposed to do this?
Divide 85.
Yeah, if you have 2 logs being subtracted, you can put them together. You just write the log once, and you divide the arguments. So that's log base 2 of 80 divided by 5. So 80 over 5 is 16. So now we can think about the log is asking us for the exponent, so you might just be able to write it down. 2 to what power equals 16? 4. If you struggle with that a little more, you're welcome to set it equal to x. So 2 to the x power equals 16. And look at it that way too. Let's try a few equations with logs. So the first one, my base is what? E. So if I wanted to write this without a log, I would write E to the 5th power equals x. And you can just leave your answer as e to the 5th. It's not a nice number even if you did multiply it out. So we'll just leave it like that. Second one. So ln tells me my base is e. If we do the definition, that means e to the 3rd power equals x squared minus 1. If you were going to get x by itself, we would add our 1 over. Then to get rid of a square, when you add a square root, it's plus or minus. When I think about this though, properties of logs tell me my argument always has to be positive. So you just need to check. If I do a plus or minus, will this still turn out to be positive? If I square a positive, it's positive. If I square a negative, it's positive. So in this case, it is okay to have both. But if one of those made the argument positive, we could not include it. Or made it negative, excuse me. We could not include it. So we get e to the 3rd. Plus or minus the square root of e to the 3rd plus 1. If you wanted a decimal, you could certainly plug that in your calculator and get a decimal equivalent. But I would also accept this. So with exponential problems, when we first did these last year, we always got a common base. So if it were like 2 to the x minus 5 equals 8, that would be no problem, because we know 8 is the same thing as 2 to the 3rd, so you could say x minus 5 equals 3. But can I get a common base between 2 and 3? No. So if we can't get a common base, does anyone remember what we did? Yeah, we added logs on both sides. Typically we just did a common log or a natural log because if we needed a decimal, those were the buttons we had available on our calculator. But technically you could do any base you wanted. The reason this is helpful is our properties of logs. Where does this exponent go? x by itself. I could just divide over my log 2. And divide my 5. Again, you could leave your answer like this. If you put it in your calculator, just remember when you push the log button, it opens a parenthesis, so you do have to close it if you type it in. So log 3 divided by log 2, closing both of those parentheses. So it turns out to be about 6.585. Last one. So we can't get a common base. We can add a log, any log we want. If we have e's, what log did we typically do? So the reason we did that, exponents come down, but if you don't remember it, it's fine. You can divide over the natural log b, but we also knew that's equal to 1 because it's saying e to what power equals e. So that's just a 1, so that cancels. So then we could subtract our 5, divide by -3. And you can certainly leave it that way if you typed it in and got a decimal. It's 0.8991. So either of those is fine. Questions about these? So I want to give you guys time to work so you can ask questions.